So let's talk a little bit about 1Integrate in transportation. So as I was mentioning earlier, transportation is one of the key vertical markets that we focus on in 1Spatial. And in fact, in the UK and Irish business, it's actually the fastest growing vertical market that we have. And what I wanted to do is just a couple of things. Firstly, give you an idea and examples of some of the customers, and then we'll go into one of the projects that we're actively working on in the moment. So we work with a number of organisations in the transportation sector, and here's just a couple of examples. And the first one I've picked is Highways England. So in the UK, we have a couple of organisations, government organisations, that are actually end up collecting the same information. So Highways England, as the name suggests, is responsible for the highways inside England, and it creates and collects spatial information around the highways of the UK. Now, at the same time, we have Ordnance Survey Great Britain, who create a product called ITN, Integrated Transport Network, which is a very, very good product, and most recently has been superseded by their highways product. And again, as the name suggests, that covers the road network across the UK. Now, as you can imagine, when two sets of information are collected independently, you often get differences, and that's not a bad thing, because one data set might be richer in certain elements than the other data set, and vice versa. So the really smart thing is, if you combine the two data sets together, you really get the best of both worlds. And that's the project that we engaged with Highways England, such that they wanted to take the smartest parts of the ITN coverage and integrate that with their own data. And it was the use of 1Integrate that firstly was able to quality assure both data sets, identify where changes were automatically between those two data sets, and then integrate those changes found within inside the ITN coverage into the Highways England coverage. So at the end of the day, Highways England had a much richer and more accurate data set. And it was 1Integrate that automated those three process steps to enable that to happen. So that's one example in terms of how the rules engine has helped Highways England. Another organisation that we do a lot of work with is Network Rail. Now, Network Rail has a fantastic scheme that it's focused on, which in effect is to have a 15% reduction in delays of trains, and indeed increase their services by over 1,000 every day. And if you commute on the trains, I think everyone will agree that will be a great improvement in terms of the service. Network Rail does a very, very good service for the UK, but this will make a difference when trying to get from A to B. Now, to enable those sort of improvements, what's key is to be able to implement things such as automated signalling. But for that to happen, you need to have the right and accurate and current spatial data to make those decisions in terms of how automated signalling could be actually put in place. And that's something that Network Rail are now focused on, to ensure that the range of spatial data holdings that they have are all integrated together and are the most current and accurate that they can be. So one of the difficulties that Network Rail has with such a rich amount of data that they hold, held in separate databases, is to ensure that those different silos are actually all in sync with each other, such that the currency across all of them is the same. Now, one option would be to create a single database and single source of the truth, but in reality there are so many other systems and processes that hang off these individual database holdings, it's just not realistic to do that. So how we're working with Network Rail is to enable a process such that if data is changed in one data holding, that change is automatically known where it should change an alternative data holding, so at the same time every single data holding is kept up to date and current. Another area that we do work with is with Queensland Main Roads. Chris has been heavily involved in that in the past, and I'm just going to hand over to him to talk you through that. So I'd just like to take you through a demonstration now, but before I hand over to Chris to do that, let me just explain the concepts behind it. So this is one of the projects that we're working on with a customer, and it relates to smart signing, lighting and guarding. Now, in the UK, if an organisation is going to dig a hole in a pavement or in a road, and it might be to fix a water pipe or a gas pipe or something of that nature, Before the work can take place, a survey plan needs to be created to show where the cones will actually be laid out around there, which traffic signs need to be implemented. Indeed, it might be if a set of traffic lights are needed. So how those cones and traffic lights or indeed signs are actually placed are all governed by a manual, and that's known as the Traffic Signs Manual Chapter 8. It's quite a riveting read if you ever want to have a look at it. It's about 355 pages of rules that need to be adhered to and when those survey plans are created. So it's not a simple process. So the process that organisations that need to create the survey plans actually go through, they normally need to send teams out into the field to survey that particular area. And indeed the survey plans that finally get created need to adhere to those 355 pages worth of rules. And that's not a simple process for two reasons. Number one, it's very time consuming and normally takes a couple of weeks for those survey plans to actually come to fruition by the time teams have been on site and the plans are actually drafted. The second concern is that are those 355 pages worth of rules actually being adhered to when those plans are created? So working with an organisation, we were tasked whether we could come up with a process to actually implement the creation of those survey plans utilising 1Integrate. Now, we took this on and we've run through a prototype that we've just come to the end of with some very successful results. Now the way we've done that is to utilise 1Integrate and actually use the vast array of data that is already out there and available to us. So in this example we use Ordnance Survey's master map data, we use some speed limit data, we use some traffic flow information, indeed asset inventory. And what we're able to do is then utilise those rules that are governed within inside that Traffic Signs Manual Chapter 8 and actually create those rules inside 1Integrate and then apply those to the data sets that I've just mentioned and in effect automatically create that survey plan as opposed to needing anyone to go out into the field. Now, you'll see that being demonstrated by Chris live and you'll see how we're actually able to do that. But the reason the organisation really wanted us to start having a look at it was when we started to assess what the real cost is to that organisation. So if you look at the UK, the first thing is there's about 2 million plans that get created every year, and there's a rough estimate of each plan costing about £1,000. So if you look at and correlate that across, that's about £2 billion spent on creating those survey plans. Now, if we're able to automatically create those plans, i.e. we don't need to send people into the field, we hugely reduce the time and cost to actually prepare those plans in the first place. The second element is actually if those plans aren't accurate in the first place, when the survey teams go to site, often they will be taking the wrong set of assets with them, so the wrong number of cones, the wrong number of signs, or indeed traffic lights. And actually the customer that we work with estimated it cost them about £2.5 million per annum in what they call as wasted journeys. But if you automatically create these plans in accordance with the rules within inside Chapter 8, you can ensure that you're going to be taking the right inventory every time to that particular location. The third element is that in the UK there are corporate fines that are handed out to organisations who don't get those works correct in a particular area. So for example, if the traffic works aren't set up in the right way, it can cause incredible congestion and therefore public distress. And in fact there's a very interesting article back in March of this year, 2018, where BT were actually fined up to £90,000 for poor traffic works in Bishopsgate. And if you Google that anywhere, you'll see an interesting picture of two buses going head to head trying to get round some traffic works. So it is a real problem. But again, if you get the plans right in the first place as governed by the Chapter 8 rules, you ensure that that doesn't actually occur. What you can see on screen is a survey plan created in its traditional way. So as you would expect, you'll see the blue area there, which is the area which is going to be dug up, and then you can see the various signs that need to be placed around the area. And as I mentioned earlier, this process to create this plan, because it needs survey teams to be sent on site, because it needs this to then be drafted, probably takes 4 people 2 weeks to actually create. And this particular plan, which is a little bit more complex, probably costs an organisation about £5,000. What we're actually able to do is automatically create this plan in the space of a minute, as opposed to taking 4 people 2 weeks. And I'll hand over to Chris, who will actually show you that happening live.
Thanks, Duncan. So here we are in 1Integrate, and if I go to my Sessions tab, and I go to my Demos Roadworks tab, you can see that there are several scenarios in here, and each scenario corresponds to a section out of the Traffic Works Act that Duncan was referring to. So firstly I'm going to look at scenario number 1, so I'll click on that, and then I'll go to the Tasks tab. And you can see the first thing we do is we open the data and read the data in, and then we're going to do a little bit of checking on the data, working out what sort of things we're going to be doing and what sort of road signs, etc., that we need to lay out. So I'm just going to kick that process off by clicking the play button here. And whilst I do that, I'm just going to switch to GeoCortex and show you the area that we're working on. So I'm going to go to a bookmark, and I'm going to go to scenario 1. So in scenario 1 you can see this is the area that we want to do the road work. So it's in the pavement. If I zoom out a little bit, you can see that it's actually in the pavement, and you can see it's quite a small set of roadworks, and it only takes up less than half the width of the pavement. So we probably don't need any traffic lights or anything for this type of roadworks, but we'll run the process through and we see what we can get. But I will run the process through and we'll see the results that come out from it. So I switch back to 1Integrate, and you can see that the data is loaded. So I'm going to run that first section through. And what that section's really doing is beginning to understand what type of roadworks we're going to be doing. Is it inside the road? Is it inside the pavement, etc.? And the next section that you can see here that we're going to run through, by the end of this section, when we get to this action here, we will know what type of scenario we're running. So I'll just kick that off now. So this section works out what scenario we're running. So it will have worked out that we're running a scenario 1. Then based on that information, we can then run the next sections to determine what sort of cones, markups, etc. that we need to put out in the road. So we'll run this section through, and that works out a safety zone around the works area that allows us to dig the rubbish out of the ground and put it to one area. It also protects pedestrians as they're walking past. And then we're creating the working space limits to understand where the work's actually going to take place. So we might need to get a lorry in to remove any rubbish, etc., etc. We need to allow for that. So I'll kick off the final section, which is going to put out any cones, any extended safety area, lane closures that we might need, traffic lights, etc. Out into the database, and then we commit the data back to the database, the last point there. If I then go back to my GeoCortex viewer and I refresh the screen by zooming in, there you can see that we've created a works area around this section, and we've given it enough room to be able to dig the shale out of the hole and put it to one side, and this will also be protected by barriers. So that's initially quite a simple scenario to look at. Now we'll go and look at a bit more of a complex scenario. We'll be looking at scenario 2. So if I go to my bookmarks tab again and I click on scenario 2, the system windows me to scenario 2, and if I zoom in a bit, you can see that this is now in the pavement, but it's taking up quite a large section of the pavement, so we may need to direct the pedestrians into the road and round the works area. So if we go back to our 1Integrate session and I pick on scenario 2, this scenario is going to run through without any pauses in it, so it's just going to go from start to finish. So I'll just kick the process off here. So it's fair to say at this point that all of the scenarios are covered by a single set of rules and actions and are completed with a single set of rules and actions. During that processing, we will determine what type of scenario we're working with and therefore what type of barriers, etc. we need to put out. You can see that it's finished processing now. So if I go back again to my viewer here, this is a GeoCortex viewer, and I refresh by zooming in or out, there you can see that we've got some more information here. We've got road narrows ahead signs, we've got end of roadwork signs, we've got road narrow ahead here. We've also got a keep right arrows, we've got cones in place. If I zoom in a little bit, you see we've got pedestrians keep right and pedestrians keep left, and we've got an area for pedestrians to walk around and then a safety working area around that, automatically defined by that same set of business rules. And then finally what we're going to do is we're going to look at a much more complex scenario, something akin to the one that Duncan showed at the end of his presentation, and this will be scenario number 6. So I'll just go to my bookmarks page again, and I'll go to scenario 6. And this one you can see we're trying to dig a hole here which is in the road. Not only is it in the road, it's also at the junction here, a three-way junction, which means we're going to need to have signage up the 3 sets of roads, but also there's a little cul-de-sac here that means we may have to use that. Each of the signs are given a distance from the starting point, so from where we dig the road, each sign must be so far away from that point, and each sign must be so far away from its previous sign. So if I go back to my 1Integrate session here, and I go to the next scenario, number 6, I go to the next scenario, number 6. Again, what I'm going to do is I'm going to run this scenario through from start to finish. One of the things we can also do as part of this processing is to actually build an inventory list so the people know what type of signage to take out and therefore what type of signage to bring back, because there are fines if they leave signage behind at the scene when they clear up. And you can see now that that's finished. So if I go back to my viewer here and I refresh my viewer again, you can see now that we've got lots and lots of signs out. We've got cone signs, we've got traffic light signs, we've got directional arrows, we've got roadwork signs, we've got three-way traffic signal signs, everything that you need. Roadworks ahead left, so they're left arrow by the roadwork sign there, automatically generated from a standard set of rules using 1Integrate and using all the information that we can gather about the road, the speed of the road, the sorts of houses that are around it, and so on. One of the things we can also do is to build a buffer around the roadworks, find out the houses that are affected, and automatically generate letters that can either be hand delivered or posted to the houses that are affected. Thank you for listening.